Hello friends. So we have already discussed how to solve differential equation of first order and first degree of these two forms till now. Those two videos are link of those two videos are given in the description box. You may watch if you want. So this form which can be solved by variable separable method, and this is homogeneous equation, how to solve homogeneous differential equation. We have already discussed. Now today we are going to discuss how to solve differential equation of this form, which is reducible to homogeneous. This is actually not homogeneous, it is reducible to homogeneous. Sorry. So there we will get two cases. So let me show you how to solve differential equation of this form. How to solve this kind of a differential equation? First, case 1. So if in this case a by capital S is not equal to small b by capital B, then how to solve? Then we will consider that small x is equal to capital X plus H, and y is equal to capital Y plus K, where H and K are constants. Where H and K are constants. Then in such case, if you consider these two, then dy by dx, small d small y by d small x will be d capital Y by d capital X. If you differentiate, you will get this from these two equations, because here you see H and K are constants, so we can write dy by dx is equal to d capital Y by d capital X. So here you see, then this equation number 1 is become of this form dy by dx. Sorry, now we will write capital Y d capital X. Then we will get, so small x is replaced by capital X plus H, plus b, y is replaced by capital Y plus K, then small c, then capital A, again capital X plus small h, capital B, capital Y plus small k, plus capital C. So we will get of this form, and if you simplify this, then it will be reduced to of this form ax, sorry, capital X uppercase X, B uppercase Y, plus A small h plus B small k plus small c, then again capital A capital X plus capital B capital Y plus capital A small h plus capital B small k plus capital C. So this become of this form. Then we have to choose two values of H and K such that these parts become 0. These two parts becomes 0. Okay, so then that means we are going to solve these two, pk plus c is equal to 0, and h plus capital B k plus capital C is equal to 0. If you solve these two, you will get two values H and K. You will get two values for which these two becomes 0. Okay, then this equation will be reduced to, if you choose such values of H and K for which these two are equal to 0, these two becomes 0, then this equation is, the differential equation will be reduced to of this form, and which can be further expressed as function of y by x, which is homogeneous. Okay, then you can apply the variable separable method. Okay, now let me show you one example how to solve this kind of equation. Suppose we need to solve this equation. First, what we're gonna do, we are going to compare with this one with a small x plus small by plus c, and the denominator will be compared to ax plus capital by plus capital C. And if you compare, then you will get that small a is equal to 2, small b is equal to 9, and small c is equal to minus 20, and capital A is 6, and capital B is equal to 2, and capital C will be equal to minus 10. So here you can see small a by capital A, that is 2 by 6, which is equal to 1 by 3, and small b by capital B is 9 by 2. It is obviously not equal to small a by capital A. So what we're going to do, we are going to replace small x by capital X plus h, and small y by capital Y plus small k. Okay, so where small h and small k are constant. So then suppose let it be suppose this is equation number 1, then this equation number 1 is going to be reduced to d capital Y by capital X is equal to a capital X plus b capital Y. That means let me write, instead of a b c, directly twice capital X plus 9 capital Y plus twice h plus 9k minus 20, and 6 capital X plus 2 capital Y plus 6 small h plus 2 small k minus 10. So this become of this form: small a capital X plus small b capital Y plus small a small h plus small b small k plus small c by capital A capital X capital B capital Y capital A small h capital B small k plus capital C. So this is of this form. Okay, now from here you see, so we have to choose such two values of h and k such that these parts become 0. So then we are going to solve these two equations, twice h plus 9k minus 20 and 6h plus 2k minus 10 equal to 0. So if you solve these two equations using any method of solving linear equations, then what you will get. So let me write the coefficients of k first, 9 and 2, then constant term, suppose. So here minus 2 minus 20 minus 10, then coefficient of h are 2 6, then coefficients of k again, then 9 and 2. So if you solve these two, so h by 9 into minus 10, that's going to be minus 20 10 90, and here plus this is 40. And so hope you know how to solve linear equations. So it's very simple. So minus 120, so plus 20 here is equal to 1 by 4 6 9 54. So that's how you can solve. If you solve this, then what you will get, so h by, that's going to be minus 50, and here it's this should be k, so k by here minus 100 and is equal to minus 50. So if you divide all terms by minus 50, then you will get here 1, here 2, here again 1. So then h will be equal to 1 and k will be equal to 2. So we have got h and k respectively 1 and 2. So as we have solved these two equations such that here you see, that means what we have got for these two values of h and k, this part here you can see in this differential equation will be 0. Okay, so we will get only this part here. dy by dx will be d capital Y by dx will be, so what is the remaining part here, twice capital X plus 9y. So let us write this one, plus 9 capital Y by 6 capital X plus, so let me check again, 2 capital Y. Okay, 2 capital Y, that's what you will get. Now it can be written in this form, 2 plus 9 capital Y by X, isn't it, and 6 plus 2, in this form we can write, which is function of y by x, isn't it? So that means it is homogeneous now. So let us apply variable separable method. So let us put here y, capital Y is equal to capital B capital X. So B will be equal to capital Y by capital X, and if you differentiate it with respect to x, then here capital D by D capital Y by capital D capital X, that's going to be B plus X dV by dx. That's what you will get. Then this equation will becomes, and this becomes here this term can be replaced by this, here you see, so B plus X dV dx, 2 plus 9, so dy by dx will be y by x will be replaced by v. So then in that case, so what we will get, 9b, 2 plus 9b by 6 plus twice b, that's what you get, isn't it? So if you applied a variable separable method, so before that let us shift this v to other side, and if you simplify that, twice x plus 9b by 6 plus twice b minus b, and if you simplify that, then what you will get, 2 plus 3 b minus twice b square, so 6 plus 2b. So I have written directly. I hope you can do the simplification part by yourself. It's very simple, not so hard. So then let us separate the variables. Then we will get 6 plus twice b by 2 plus thrice v minus 2v square dv, on the other side minus 1 by x dx. Okay, so here you see what we have done. We have taken we have multiplied minus 1 on both sides, then what you will get, so that this quadratic terms become positive. That's what we have done, 2v square minus 3v minus 2 dv. So here it will be minus 1 by x dx. So now let us integrate on both sides. So now what you will get, so here you see, if you factorize this denominator, this part, then what you will get, if you factorize, then you will get v minus 2 into twice v plus 1. That's what you will get. I hope you know factorization. It's you have already learned in class 8 or 9 standard. So 6 plus 2 v, that's going to be v minus 2 into twice v plus 1 dv minus integration 1 by x dx. So now what we will get, we will apply partial fraction. So here v minus 2 twice v plus 1, so 6 twice v, it can be written as 4v plus 2 minus 2v plus 4. So here you see 4v minus 2v, that's again becomes twice v, and 2 plus 4, that will be 6, isn't it? So that's what we have done. So here minus 1 by x integration dx. So now here this can be, so here so now this expression becomes, here you see, if you take 2 common, twice b plus 1 become minus 2 b minus 2. So here you see, okay, b minus 2 into twice b plus 1. So it can be separately written twice b plus 1 by b minus 2 into twice b plus 1 minus 2 into b minus 2 by b minus 2 into twice b plus 1. So here then this expression will be reduced to 2 by b minus 2 minus 2 by twice b plus 1, isn't it? So what we have got now, so we have here, you see, we can write this left hand side as integration to integration 1 by b minus 2 db minus 2 integration 1 by twice b plus 1 dv minus integration 1 by x, sorry, here it should be capital X dx, isn't it? So that's what we have got. Let me clean this part, sorry. So after integration, if you integrate this, then what you will get, log of b minus 2 and minus 2, here it will be, here you see this part. So this 2, let us keep this 2 here, okay. So now you see this is of this form, integration f dash x by f of x dx, which is equal to log of f of x, because if you differentiate this, then you will get 2, isn't it? So therefore we get log of 2b plus 1 and minus, so integration of 1 by x is log x, here we should write capital X, then plus c is constant. So let me clean this part here. So that's what we have got after integrating the above equation. So this is suppose c. So now what we can do here, so this is 2. We know that suppose we have n log m, then it can be written as log m to the power n. This is property of log. So applying this here, so we can write log b minus 2 whole square. Again you see one more thing, log m minus log n, you can write log m divided by n, isn't it? So if you apply that property, then you can write here b minus 2 whole square by twice b plus 1. So and then if you bring this log x to this side, you will get plus log capital X on the other side. Instead of c, let us consider this is log c, okay, log c. So now let me scroll down. So again log m plus log n, another property we have, log m into n. So applying that, we will get log b minus 2 whole square into x by 2b plus 1. So this x is capital, okay, is equal to log c. So that's why it implies b minus 2 whole square capital X by twice b plus 1 is equal to c. That's what we have got now. So b can be replaced by y by x, isn't it? B is equal to y by x, as we have considered y is equal to bx. So that's why if you replace the b by y by x, then what you will get, capital Y by x minus 2, sorry, it's capital X minus 2 whole square into capital X by 2 capital Y by X plus 1 is equal to C. That's what you will get. So if you simplify this, then what you will get after simplification, we will get capital Y minus 2 capital X whole square is equal to C into twice capital Y plus X by capital X. That's what you will get after simplification. Sorry, not X there, just this equation you will get. Okay, so we have considered that small x is equal to capital X plus h, so capital X can be replaced by small x minus h. So similarly, capital Y can be replaced by small y minus k, isn't it? And we have got the value of x, h and k that we have already evaluated. So what were those values? So let me show you. H is equal to 1, k is equal to 2. So let me scroll down the page. So capital X should be replaced by small x minus 1, and capital Y should be replaced by small y minus 2. So if you replace this capital Y and capital X using by these two values of capital X and Y, so then what you will get? Then we will get y minus 2. So this capital Y is replaced by y minus 2, and minus 2 into x is replaced by small x minus 1 and whole square. On the other side, c twice y is small y minus 2. So let me use curl bracket here. Then plus x is x small x minus 1. So that's what we have got. Now let us simplify this. So small y minus 2 minus twice x plus 2 whole square, small c, this c is constant of integration, then twice y minus 4, then plus x minus 1. So if you simplify this, then what you will get? Here plus 2 minus 2 cancel, and so we will get here y minus twice x whole square. So on the other side, small c minus twice y plus x minus 4 minus 1, that's going to be minus 5, isn't it? So that's our result. That's our answer. Or you see, as it is whole square, you know, a minus b whole square, if you write b minus a whole square, then also correct, result will be same, as that is whole square, isn't it? So similarly, so this result, if you follow certain books, and that book same question, answer to the same question may be given in this way, twice x minus y whole square. Okay, so it will be equal to this one, and c into twice y plus small x 5. So this is our answer. That's how we can solve. Now let us discuss case 2. Okay, so we have discussed this case that if a small a by capital A is not equal to small b by capital B. Now case 2, in this case we will discuss how to solve this kind of equation, that equation reducible to homogeneous, which is of this form: dy dx is equal to ax plus b, sorry, yes, bx plus c, sorry, not bx, by, then capital Ax plus capital By plus capital C. So this form, if small a by capital A is equal to small b by capital B, then how to solve this kind of equation? Then you see, if small a by capital A equal to small b by capital B, then let us suppose it is equal to 1 by m for some constant m, say, then this a will be equal to a small a into m, and capital B will be equal to small b into m. That means this small a and small b must be multiples of a and b respectively. So if this condition is satisfied, small a by capital A equal to small b by capital B. Okay, so hope you have understood this. So then this equation, this given equation will be reduced to this form: d small y by small x, d small x, ax plus by plus c, and capital A is small am and capital B is small bm. If you put and simplify, then you will get this form. Okay, so then from here you see it can be expressed in this f by y form, function of x by y, y by x, which is homogeneous. Then you can apply the variable separable method. Okay, so let me show you one question. Question how to solve such type of question. So now let us solve this question. So here it can be expressed in this way: dy by dx. So here it will be minus twice x plus y plus 1 divided by 4x plus twice y minus 1. Okay, so here if you compare this one with this form, so this form of equation, then you will get a is equal to 2, small a is equal to 2, b small b is equal to 1, and capital A is equal to 4 and capital B is equal to 2. So if you find a1 by a2, okay, small a by capital A, not a1 by a2, then 2 by 4, that's going to be half, and similarly small b by capital B will be also half. So here you see small b by capital B, small a by capital A equal. So here you can see that capital A is 2 times of small a and B is also 2 times of small b. That means here that means in this case m is equal to 2. That this m here, the value of m is 2. So that's why now this equation dy by dx, it can be written as minus twice x plus y plus 1, and 2 here it can be written as 2 into twice x plus y minus 1. We can express this way. So if you 2 times this term within bracket, then you will get this denominator as it is. Okay, so now here you see what we're going to put here. So we're going to substitute this term by some other variable. Suppose let twice x plus y be t, small t suppose. Then if you differentiate with respect to x, then you will get x plus dy by dx and is equal to dt by dx. Okay, so which implies dy by dx is equal to dt by dx minus 2. Now so we are going to replace this part and this part by t, and this dy by dx will be replaced by this dt by dx minus 2, and doing so what we will get, dt by dx minus 2 will be equal to minus t plus 1 by twice t minus 1. That's what we have got. So now let us proceed from here. So what we can do, if you simplify this, you will get dt by dx is equal to minus t plus 1 by twice t minus 1, minus 2 will be plus 2 on the other side, isn't it? So what are we going to do now? So let us simplify this right hand side. After simplification, the right hand side becomes 3t minus 3 by 2t minus 1. Okay, so from here what we can do now, you see if you apply the variable separable method, then you're gonna have so twice t minus 1 by 3t minus 3 dt, and on the other side you will get dx. Okay, so that's what we have got. So hope you can do yourself the simplification part. It's very simple. So if you simplify this equation, you will get this. Okay, hope you have understood how they get it. Okay, now what we are going to do in this case. So if you see, if you multiply both side by 3, then what you will get? Then you will get 2t minus 1 by t minus 1 dt and 3 dx. That's what you will get. Okay, so now again we are going to apply the partial fraction. So here this minus 1 can be written as this minus 1, it can be written as that 2t minus 2 plus 1 t minus 1, then dt 3 dx. So from these two terms, if you take 2 common, then you will get t minus 1 plus 1 by t minus 1 dt is equal to 3 dx. Then if you simplify this, then what you will get? Then you will get 2 plus 1 by t minus 1 into dt is equal to 3 dx. Now let us integrate both sides. If you integrate both sides, then you will get 2 integration dt plus integration 1 minus 1 by t minus 1 dt 3 integration dx. That's what you will get. So hope you have understood this till now what I have explained. So integration of dt will be t only, and integration of 1 by t minus 1, that's going to be log t minus 1. That's very simple integration. And integration of x is x, then we need a constant here, so constant of integration. Then let us replace the t. We have considered t is equal to what? Twice x plus y. That's what we have considered, isn't it? So here you see this twice x plus y term is considered as t. So if you replace the t by that term what we have considered, twice x plus y, then here it will be log of twice x plus y minus 1 and 3x plus c. That's what we have got. So that's our answer. So this is our answer. That's how we can solve it. So hope you have understood this. So if you think this is helpful for you, then please share the video. And if you are new to my channel, please subscribe the channel and help me to grow my channel for new contents. Inspire me to create new contents for you. Thank you for watching.